basically two methods. I'll repeat. There are basically two methods for measuring the angles using theodolite. First one is the repetition method. So this method is used for accurate work. Say in the figure, you have angle AOB. So you want to find the angle AOB using the theodolite. So if you are very particular or very serious about measuring this particular angle, you can go for the repetition method. By the word, it means that you are repeatedly taking this angle 2 or 3 times and taking the average to find the most correct value, AOB. So in this method, the same angle is added several times and the correct value of the angle is obtained by dividing the accumulated reading by the number of repetitions. So initially, suppose you got the value as 30 degree, then again you take the angle, then it may multiply to 60 degree if it is very correct, or it may be 61 degree. So initially it was 30 degree, now 31 degree. So the average will be the best possible answer for this angle. So in this procedure, set up the theodolite at starting point O and level the theodolite at this station. Bisect A accurately with A vernier. So first you bisect it with the A point and then turn the telescope to site point B. Now the vernier gives the horizontal angle AOB. So to remember regarding the clamps, I have just made a figure. So consider this as the theodolite. You have a lower clamp and upper clamp. So when you release the lower clamp, the entire instrument means the telescope part will get rotated with the base plate. If you are tightening the lower clamp and if you are releasing the upper clamp, the angle will change, right? So first you release the lower clamp by keeping the upper clamp tight, bisect the A, then turn the and make and then you release the upper clamp and make it 0, 0. Then release the upper clamp and sight the point B. Now the vernier gives the angle AOB. Then again loosen the lower clamp so that the angle is not changing, and you will again sight to A. Then again you will release the upper clamp so that the angle is varying, and you will get the next angle. That means it will be almost 2 times the angle AOB, and bisect accurately by the upper tangent screw, and the verniers will read the twice the angle now. So that is about the repetition method. And the difference with reiteration method will come in the next slide. So before that, the repetition, the process until the angle is repeated for number of times. Usually we are taking 3 readings, and the final reading after n repetitions should be approximately n into x the angle. Divide the total angle obtained by number of times will give you the average value of the angle AOB. So the reiteration method is also a method which is used to get more accurate angle. But in this case, the concept is little different. Here we can see in the figure, we have point A, B, D, and C, right? So if we have numerous points around the single station point, to get the angle AOB, BOD, and DOC to the maximum correct value, you can go for the reiteration method. The idea is that when you start from A and you are rotating, if it is in clockwise, it will sight from A to B, B to D, D to C, and you will again stop at A. So if the initial angle was 0 degree, when you close it, you should get 360-degree angle. Suppose if there is a error of 1 degree, divide that 1 degree to all the individual contributions. Okay, so there are actually 1, 2, 3, 4 angles. So 1 degree means you have to divide it to the 4 angles. So it is another precise and comparatively less tedious method of measuring the horizontal angles. It is generally preferred when several angles are to be measured at a particular station. So that's this case. This method consists in measuring several angles successively and finally closing the horizon to the start point. This starting from A, ending with A. Final reading of vernier A should be same as the initial reading. If there is some mismatch, then equally divided to all the angles. So procedure is set up the instrument at station O here, direct the telescope towards point A and bisect it accurately. That means the lower plate as well as upper plate should having 0 coinciding, and it can be either the vernier reading should be 0 or 360 degree. Then loosen the lower clamp and turn the telescope clockwise to point B exactly. Then read the verniers again, and the main reading will give you the angle A or B. Similarly, sight C and D, then read both the verniers at each bisection, find the value angle BOC, this angle, and COD. Finally, close the horizon by sighting towards the reference point A. So you are starting from here, ending with here, and at this point, the vernier should read 360 degree. If not, note down the error, and this error is due to the slip. If the error is small, then equally distribute among all the angles. If the error is large, the readings should be discarded and no set of readings has to be taken. So like say if the error is up to 1 degree, you can consider that and divide to all the points. If it is very high, maybe some 5 degree, 10 degree, you can again redo the experiment. A drawback with this reiteration method is that suppose if the point B is not there, AOD is the biggest angle, COD is there, then COA is there. By this method, you are supposed to divide the angle equally with all the members. All the, not members, all the angles. So being this one a big angle, this should have a big proportion. But in here, we are equally dividing. So that is creating some errors. So a more good way is that you should divide that error in a proportionate way. So today's experiment is to find the horizontal distance between 2 points P and Q. So the peculiarity of this 2 points P and Q is that they are inaccessible. So what is that? We can see the P and Q is fine. Actually, I'm standing at here, and I may notice there is a river or any other obstruction which is not permitting me to directly take tape reading from here observer to the Q as well as between these 2 points. So we only know that there are 2 coconut trees or any 2 objects here. We want to measure the distance between these 2 points. So we can't directly measure it. So for solving this problem, we can use the theodolite. How? So as the first step, you should have a point A as the instrument station 1 also should take one more instrument station B. Right. Then in the next step, do the theodolite surveying. That is keeping the instrument at station A, first sight to P, then sight to Q, then sight from A to B, then again you close it to P. Just a minute. Yeah. So you're first measuring this angle, then you are measuring this angle, then you are rotating it and closing again at P. So this method is called as the reiteration method. So you got all the values. So this can be done very fast, because if you're doing a repetition method, it will take more time. So this reiteration method will be a good option for A. Then after that, shift the instrument from A to B. Then from B, you can take all the readings. Like you can first sight A, then first angle will be angle ABP. Then again, second angle is PBQ can be found after deducting the total angle from this small angle. Then again, it is continuing and it is closing again at the A. So here also the reiteration method can be used, and if there is any closing error, we can divide it into all the angles. So there are some objects for this P and Q, but this A and B are assumed, or the station points we proposed. So you should keep a ranging rod at B when you sight from A, and similarly when you sight from B to A, you should keep a ranging rod here. Then only you can easily find the points. So now we know all the angles in this quadrilateral, and you can write the θ1 angle, which is this, θ2 angle here, θ3 is here, θ4 is here, and you can directly measure the distance A to B. It is known to you. Then after all these readings, we can solve for different triangles, and we can finally find the distance between point P and Q. That will be the work for you. So I will share this Excel sheet to you, which includes the values. That is, here you can see the point A, the point B readings, and from point A we have taken sight to P, Q, B, again closing with P. So the vernier A and B scale values, and the mean values are also given. So you can correct the angle if there is any closing errors. Similarly, this is done for left face right swing as well as the right face left swing. All the values are given here. You can, for right face left swing also, you can find the correct angle and take the average for getting θ1, θ2, θ3, θ4. Then you can solve, as we explained in this figure, we can find the distance PQ. So this will be your work for today's lab session, and I have already shared the writing material or the procedure parts as a Word file in the WhatsApp group. So you can refer that the Word file, and I will share this Excel sheet also with you, and you can solve for the distance PQ. So that's all for the today's lab session. So have any doubts, you can ask me now. Now it's open for discussion or any queries. So this is actually a simple experiment. In this lab, we learned the importance of reiteration method. So we use the reiteration method for finding the angle from point station A as well as B, as we have numerous angles to take from point A as well as B. The reiteration method was an ideal choice because the repetition method will take more time, and we are not focusing on a single angle, we're taking multiple angles. So the reiteration method was an ideal option for this case, and we learned how to measure distance between 2 points which are inaccessible. So that's the experiment on find the distance between 2 inaccessible points. So any doubts? Farouk is here. Farouk CN. Farouk. Gada. Message mic unmuted है. Devika.
Yes, sir.
Yeah. Clear ആണോ പറഞ്ഞതൊക്കെ?
Sir.
Doubts ഒന്നുമില്ല. Hello. Deepak.
Yes, sir.
Everything fine?
Yes, sir.
കുഴപ്പമില്ല. അങ്ങനെയാണെങ്കിൽ ഇത് ഇത്തിരി സിമ്പിൾ ആണ്, ബിക്കോസ് നിങ്ങൾ ലാസ്റ്റ് ടൈം നിങ്ങൾ തിയോട്ടലായിട്ട് ചെയ്തതുകൊണ്ടും റെപ്പറ്റേഷൻ മെത്തേഡ് എന്ന് അറിയാവുന്നതുകൊണ്ടും ഒരു ചെറിയൊരു ചേഞ്ച് മാത്രമേ ഉള്ളൂ. as I explained. So നിങ്ങൾക്ക് അരുൺ സാർ ഉണ്ടോ മീറ്റില്? Arun sir is here. I think no. So do one thing. Lab നമ്മൾ വൈൻഡ് അപ്പ് ചെയ്യാണ്. നിങ്ങൾക്ക് വീഡിയോസ് കാണാം. ഞാൻ പറഞ്ഞ പോലെ എല്ലാ ലെഫ്റ്റ് സ്വിംഗ് റൈറ്റ് സ്വിംഗിന്റെയും ലെവലിങ്ങിന്റെ എല്ലാത്തിന്റെ വീഡിയോസ് അതിൽ അവൈലബിൾ ആണ്. നമ്മുടെ ഗ്രൂപ്പിന്റെ ഡിസ്ക്രിപ്ഷൻ ബോക്സിലും ഞാൻ ആ ലിങ്ക് ഇട്ടിട്ടുണ്ട്. അപ്പോൾ നിങ്ങൾക്ക് ഡൗട്ട് ഉണ്ടെങ്കിൽ കാണാം. വൈവ അറ്റൻഡ് ചെയ്യാനുള്ളതിൽ ആദ്യത്തെ 4 പേരായിരിക്കും ഞാൻ ഇന്ന് വൈവ കണ്ടക്ട് ചെയ്യുന്നത്. ബാക്കി 4 പേര് അരുൺ സാർ ആയിരിക്കും. അപ്പൊ അതില് ഒരാള് അരുൺ സാറിനെ വിളിച്ചിട്ട് സാറിനോട് ലിങ്ക് പ്രൊവൈഡ് ചെയ്യാൻ പറയാം. എന്റെ ലിങ്ക് ഞാനിപ്പോ ഗ്രൂപ്പിൽ പോസ്റ്റ് ചെയ്യാം. ഓക്കെ, ദാറ്റ്സ് ഓൾ. പിന്നെ റെക്കോർഡ് ഇപ്പൊ എഴുതണ്ട. ഹോസ്റ്റലേഴ്സ് ആണെങ്കിൽ നിങ്ങൾ തിരിച്ചു വന്ന് നിങ്ങൾക്ക് എഴുതാൻ പറ്റണം. ഇൻ സെൻസ് വർക്ക് ലോഡ് കുറെ ഉണ്ടാവും, അപ്പൊ ടൈം മാനേജ് ചെയ്യാം. ഡേ സ്കോളേഴ്സ് ആണെങ്കിൽ എഴുതി തുടങ്ങിക്കോളാം കേട്ടോ. അതേപോലെ തന്നെ ഗ്രൂപ്പിലെ അടുത്ത ആള് ചെയ്ത വർക്കിന്റെ റഫ് റെക്കോർഡ് സ്കാൻ ചെയ്തിട്ട് ഗ്രൂപ്പിൽ പോസ്റ്റ് ചെയ്യുക, നിങ്ങൾ നേരിട്ട് കാണാത്തതുകൊണ്ട്. അതായിരിക്കും നമ്മുടെ ഈ ഓൺലൈൻ ലാബിലുള്ള നമ്മൾ ചെയ്യുന്ന പ്രൊസീജിയർ. ഐ തിങ്ക് എവറിത്തിങ് ഇസ് ഫൈൻ. ഡൗട്ട് ഉണ്ടെങ്കിൽ ഗ്രൂപ്പിൽ ചോദിച്ചോളാം. ആൻഡ് യു ക്യാൻ ലീവ്. താങ്ക് യു.
Thank you, sir.
Thank you, sir.
Thank you, sir.